CircuitVerse, it will come up. Okay, it is one word, CircuitVerse. So you will get some sort of a panel here, right? And you can see that you can create different kinds of gates, input, output, and so on. Okay. So let us start by putting some gates. Okay. You can drag and drop. Now let me introduce some inputs. And we can draw an output. So we can label these inputs. See, this input properties, we can say label is A. Similarly, maybe we can call this B. Then this one can be called C. And this one can be called D. Okay. It is very straightforward. So you can just drag and drop components, right. Right now the inputs are set to 0, 0, 0, 0, okay, and it has actually already simulated. Okay. See, if you place this cursor, it is telling you the value there is 1. Okay. See, this 0 causes the output of the AND gate to be 0, and as a result the output of the NOT gate will be 1. Okay. And because of that the output of the NOR gate will be 0. This is 0, right, and as a result the output here will be 0, okay, and because of that this will be 1. Okay. So you can find out the values at each of these points, right. So this is what a good circuit is doing. Okay. When I apply 0, 0, 0, 0, the good circuit simulation shows that it produces a 0. Okay. Now I want to inject a fault, let us say a stuck at 1 fault here. Okay. So we will see whether that stuck at 1 fault can be sort of caught by this guy. Okay. So a stuck at 1 fault can be simulated by putting a logic 1 here and connecting it there. Okay. So when I put a 1 here, see, unfortunately this 0 is already producing a 1 here, right, and as a result you will get a 0 here. Okay. So this NOR gate is producing a 0 because of two things. One is the 1 is here and there is a 1 here. So this stuck at 1 fault cannot be caught by A equal to 0, B equal to 0, C equal to 0, and D equal to 0. So, sorry. In order to propagate this fault, see, now we have placed a fault here. In order to propagate this, we should not put a 0, we have to put a 1. Okay. When I put a 1, at least the fault came here. Okay, the fault came here. So earlier the output here was 1, but now the output here is 0. Okay. But unfortunately, the fault is not propagating to this wire, the output. Okay. We can call the output also as out or something like that. The output is still containing 0. So we have to somehow propagate the fault is now propagated up to this point, but in order to propagate it further, we have to put a 0 here. For that reason, we have to put a 1 here. Okay. So now 1 and 0. This is 0. So, this 1 and 1 will cause a 1 here and it will cause a 0 here, and that will propagate the error to the final output. Okay. So, we can use this kind of a tool to actually argue about how test patterns can be generated. Okay. So, once again, what I had was the original circuit was this one. The original circuit had a connection here, okay, and I had applied a 0 0 0 0, and it was producing a 0 at the output. Later I said I will try to inject a fault. Okay. Maybe my interest was in locating a test vector for a stuck at 0 fault or stuck at 1 fault here. Okay. So, let me try to inject a stuck at 0 fault this time. Okay. So, I have injected a stuck at 0 fault. But in order to propagate that fault further, I need to have a 1 here, otherwise both the good and the faulty circuit will have a 1. Okay. And to further propagate the default to the output, we need to put a 0 here. That means I have to put a 1 here, which means I have to put a 1 on both these ways. Okay. So, now you can see, right, that the faulty circuit is producing a 0, right. Let us see what the good circuit will produce. The good circuit produces a 1, okay, whereas the faulty circuit produces a 0. Okay. I hope that became clear, right. Similarly, if you wanted to generate a test for a stuck at 1 fault, introduce a stuck at 1 fault like this by injecting a fault. Now, the faulty circuit also produces a 1. So, 1 1 0 1 is not a test vector for this particular fault. So, let us see, we are propagating the fault to this guy, and okay. Okay. I think again there may not be a test vector is what I am guessing. Okay, see this particular fault, I do not think we can test it. Again, I may have introduced some redundancy. Okay. So, whether I put a a fault or not, unfortunately, I am not able to propagate it to the output. Okay. But you can use it to illustrate one more point. See, now I have applied a 1 1 0 1. Okay. So, do a simulation. 1 ANDed with 1 is a 1, that produces a 0 here. 1 ORed with 0 is a 1, and this 1 produces a 0 here. Okay. So, the NAND gate produces a 0, and 0 and 0 NOR will produce a 1. Okay. Now, the question is, if I click this, I am changing D to 0, and you can see that it highlights how the changes are happening. See, once again let me do it. You are seeing this line, right. So, this path, when I change it from 0 to 1, this toggled and this also toggled and the output also toggled. That means if there is a fault on D, it will get caught. If there is a fault on this line, it will get caught. If there is a fault on this line, it will get caught. So, 1 1 0 1 is a test vector for D. Let us say D is stuck at 1. Okay. 1 1 0 1 is a test vector for D stuck at 0. 1 1 0 1 is a test vector for D stuck at 0. Okay. So, if I change it, this is also changed. Let us try one more. I have applied 1 1 0 1. What if B has a fault? Let us see what happens. If B has a stuck at 0 fault, see this is changing. So, that means this guy can detect B stuck at 0. Okay. 1 1 0 1 is a test vector for B stuck at 0. In fact, it is a test vector for many others. Okay. You can see that it is highlighting this path as well as this path. Okay. Can you see? So, it simply means that if I put 1 1 0 1, the expected output is 1, but if B has a fault, output changes, and if this has a stuck at 0 fault, also this will change. Okay. So, everything that is highlighted, there is a test. I mean, it is a 1 1 0 1 is a test vector for B stuck at 0, and this wire stuck at 0, right, and this wire stuck at 1, right. So, it is a test vector for a number of faults. So, I hope this exercise was clear to you guys. Okay. Unfortunately, this is not meant for test generation. Okay. So, it does not quite support any test generation, etc. Okay. Test generation tools are not available like this in the public domain, but you can use it to answer. See, for example, if I give an exercise to you of a fairly large circuit, okay, and if I ask you to do a fault simulation, see, suppose this is 1001, I ask you to fault simulate 1001. After you note down the values, okay, you have to say, look, a good circuit produces a 0 here, it produces a 1 here, okay, and it produces a 0 here, etc. So, note down the values of the good circuit simulation. Then toggle things. See, for example, what if A is stuck at 0? See, that does not seem to get caught. Okay, the output is not changing. So, 1 0 0 1 is not a test vector for A stuck at 0. What about B stuck at 0? It is. Okay. So, 1 0 0 1 is a vector for B stuck at 1, okay, because if I change it, the output changes. What about C stuck at 1? No, it cannot detect. Okay. What about D stuck at 0? No, it cannot detect. Okay. So, the only one which it was able to detect is B stuck at 0. In addition to B stuck at 0, it may also be able to detect a fault here. Okay, that is this wire. Okay, right now it is at 1. So, if I make it stuck at 0, you may find that the output will remain. So, when I have 1 0 0 1, I get a 0. So, we can try. we can go and try to simulate a fault here. So, no, 1001 is not a test vector for sorry, this is 1, no, stuck at 1. My apologies. So, if I had applied 1001 and this is now 1. So, 1 ANDed with 1 is 1, this is 0 and this 0 and 0 are giving you 0 here. So, it gives you 1. No, this also will not be detected. Okay, this also will not be detected. See, the reason I think B1 gets detected, but this stuck at 1 is not detected is because I think some sort of a cancellation occurs. Okay, so you please think about why B1 B stuck at 1 gets detected, but this stuck at 1 is not getting detected. So, if this is stuck at 1, 1 ANDed with 1 is 1, 1 and that becomes 0 and this guy is 1 and right now this is 0 and if I change this will change, but you see this B0 is not able to influence this. Okay. So, this guy will not be able to influence the other line. So, you have to be careful. Okay. So, B stuck at 1 will get detected, but this line getting stuck at 1 will not get detected. Okay. So, I hope this point is clear. can use Control Z to do undo. You can use Control C, Control V to copy. Okay. So now I have applied one zero zero zero. Okay, that is my test vector. The question could be, let me label these guys. So maybe the point is find a test vector for a stuck at 1 fault here. Okay. So looks like this is already 0. Okay, we have to somehow make this 0. So by putting a 1 1 here, I am able to make this 0. And in order to propagate this further, I have to use 1 here. Okay, only then it will get propagated. Okay. And in order to propagate this further, I have to make this a 0. Okay. So this, according to us, is a test vector for a stuck at 0 fault here. Okay. So how do I prove that? If I put a 1 here, this should change. Okay. If I put a 1 here, then this should change to a 0. Okay. You can verify. So let me inject a. Unfortunately, I can't directly inject a fault like that. Right now, this is stuck at 0, right? If I inject a fault by putting logic 1 like this, it will give an error. Okay. The tool will not like it. So I will get a bus contention. It will say you are trying to put a 0 and a 1 on the same wire. So you will have to delete this part. Okay. So you can see that it changed. Okay. When I had this guy and this was not there, okay, I had a 1, but when I put a 1 here, it changed to 0. So that way we can argue that this particular test vector 1 1 1 0, it's a test for a stuck at 0 fault here. Okay. So if I go back, I think Control Z will undo things. Okay. So if I had 0 1 1 1 1 0 with no fault, okay, then I had a 0 here and the output was 1. But if I go back to the same thing, see this changed. Okay. So that is a way to argue why 1 1 1 0 is a test vector for a stuck at 0 fault on this wire. Okay. I want you to be able to do this. Okay. The other thing I want you to know is what are the other faults that 1110 detects. We already know that it will detect this, right. In the same way, I may be able to detect, I may be able to toggle. Okay, no, this is not detected. Okay, the output is not changing. What about B stuck at 0? That seems to be getting detected. So B stuck at 0 gets detected. C stuck at 0 also gets detected, and D stuck at 0 is not getting detected. So you can use the method that I just described to go and test whether each of these tests I am sorry, each of these faults when injected, okay, results in a change in the output. Okay. In this example, I took a single output, okay, but I may have multiple outputs. All right, let us go back and see. I have applied 1 1 1 1 1 and the output is 1 1. Okay. So, if I try to change this to 0, that does not have work. So, this stuck at 0, let us call this wire E. So, E stuck at 0 is not detected by 1 1 1 1 1. Okay. What about A stuck at 0? No, that is also not detected. Okay. What about B stuck at 0? That gets detected here. Okay. What about C stuck at 0? That also gets detected here. Okay. What about D stuck at 0? It is not detected. So, only B stuck at 0 and C stuck at 0 are getting detected by this test vector. Okay. 1 1 1 1 1. Then you can try whether it detects a fault here. Okay. So, we can try to inject a stuck at one fault here. See, that gets detected. So, a stuck at one fault here will get detected. Okay. So, this is how you can go and do both. You can try to generate a test vector and you can also try to generate you can also try to do the fault simulation. Okay. So, this is a simple tool that I would like you to use.